So today we are going to learn expansion of gases. The first topic in this chapter is Boyle's law. Everybody must have heard of the name Boyle's law. If you haven't heard, the Boyle's law states that the volume of a fixed mass of a gas, very important, fixed mass, the volume of a fixed mass of a gas at constant temperature is inversely proportional to its pressure. Right? The volume of a fixed mass of gas at constant temperature is inversely proportional to its pressure. What does this mean? That if we take a fixed mass of a gas at a constant temperature and if we increase the pressure, then the volume of the gas will decrease, and if we decrease the pressure, the volume of the gas will increase, right? So if P is the pressure, right? If P is the pressure, then with the variation of P varies as inversely proportional to 1 by V. P inversely proportional to 1 by V, which means PV is a constant. PV is a constant. PV is a constant. Now PV is a constant. This is the equation of a rectangular hyperbola. This is the equation of a rectangular hyperbola. So if you have two axes here and this one is pressure, and this one is volume, then the graph is something like this. This is a rectangular hyperbola, and if you are drawing uh, P and 1 by V, so if this is P and this is 1 by V, so P proportional 1 by V, which V equals to some constant K by V. So this is the equation of a straight line passing through origin. So let me draw it. It is a equation of a straight line. So this is Boyle's law, and this can be explained as PV equals to constant. So you can write P1 V1 is equal to P2 V2 is equal to P2 V3, like this will be important for solving numericals. P1 V1 equals to P2 V2 equals to P2 V3. What do we know? Volume is equal to mass by density. Volume is equal to mass by density. So instead of volume, we can write mass by density. So P1 mass is constant. So P1 V m by d1 is equal to P2 m by d2. So from here we can write P1 by d1 is equal to P2 by d2, right? P2 by d2, or we can write P by d is constant. P by d is constant, which means pressure by density of a gas at a constant temperature is constant. Pressure by density of a gas at a constant temperature is constant. Okay. Now, one very important observation, right, which we see in our daily lives. Now, when we blow air into a balloon, what happens? If we blow air into a balloon, the pressure inside the balloon increases. Also, the volume inside the balloon increases, right? So, how can it be possible that the pressure is also increasing and the volume is also increasing? So, this is violating the Boyle's law. But actually, what happens is that if we are blowing air into the balloon, the mass of the gas inside the balloon also increases, right? So mass of the gas or the air inside the balloon also increases. So Boyle's law, as you have seen in the statement, that the volume of a fixed mass of a gas, right, at constant pressure, at constant temperature, was inversely proportional to its pressure. So the gas should have a fixed mass, then only Boyle's law is applicable. So in this case, if we blow air into a balloon, the mass does not remain constant. So Boyle's law is not applicable in such cases. So This was one important thing that comes in the. So our next topic is Charles law. Right. What does Charles law states? Charles law states that the pressure remaining constant. Right here in Charles law, the pressure remains constant. So the pressure remaining constant, the volume of a given mass of any gas, the volume of a given mass of any gas increases or decreases by the constant fraction, by a constant fraction 1 by 273 of its volume at 0 degree, of its volume at 0 degree Celsius, for every degree centigrade rise or decrease of temperature. Right? For every degree rise or fall of temperature. What does this means? Now, if we are taking the pressure constant, right? Pressure constant, and we have taken a given mass of any gas, and we have taken a given mass of any gas, right? What will happen if you increase the temperature? If we increase the temperature by 1 degree, then the volume of the gas will increase by 1 by 273 times of its volume at 0 degree. For example, if the volume of a gas is V0 at 0 degree Celsius, if the volume of a gas is 0 at V0 at 0 degree Celsius, then and VT is the volume at, suppose, T degree Celsius, T degree Celsius, T degree Celsius, then we can write VT is equal to V0 1 plus 1 by 273 into 1 by 273 into T, which means if we open this bracket, what we are getting? We are getting V0 plus 1 by 273 times of 1 by 273, and T is better to write T here so that there is no confusion. Better to write T here, T by 273. So this whole thing, 1 by 273 fraction into the change in temperature, into how many degrees you have changes. For example, from 20 if you want to find out the volume at 20 degree, then T is equal to 20, right? So V0 you know, and T is 20, and this change is into V0, means the volume at 0 degree Celsius. If V0 is the volume at V0 0 degree Celsius, then for T degree Celsius, what will be the change? V0 into 1 by 273 times of that temperature. Okay, for every degree, there is a change of 1 by 273 fraction. And so for 20 degree, there will be a change of 20 by 273 fraction. And that will be added to the original value V0 so that you get a value at 20 degrees Celsius. For example, if I give you a problem that the temperature, the volume of fixed mass of gas, fixed mass of gas is 10 liter, is 10 liter at the 0 degree Celsius, 0 degree Celsius. Find the volume Find the volume at 100 degrees Celsius. Please do this sum, everybody. The volume of a fixed mass of a gas at 0 degree Celsius is 10 liter. Find the volume at 100 degrees Celsius. Pressure remains constant. Pressure is constant. Pressure is constant. Hello. So the solution to this is Vt is equal to 10. Using this formula, Vt is equal to 10, 1 plus 100 by 273, which gives you 13.66 liters. Okay. So now we are going to use this formula again, and we are going to see what happens to this formula. Let's do some modifications. Vt is equal to, we can write V0 273 plus T divided by 273. Now, what do we know about the absolute scale of temperature? The absolute scale of temperature is the temperature at which, right, at which, or absolute zero temperature. Suppose what we know about, there are three types of temperature I have already discussed in earlier classes. Right? One is the Fahrenheit scale, one is the Celsius scale, and one is the Kelvin scale. So, what is the relation between Kelvin scale and degree Celsius scale? The relation between Kelvin and degree Celsius scale, I have already mentioned that in Kelvin, it is equal to 273 plus degrees T in degree Celsius. If T is in degree Celsius, then the temperature in Kelvin scale will be 273 plus T. Now, Kelvin scale is a fundamental unit of temperature, which is used everywhere, and it does not have a degree associated with it. And Kelvin is known as absolute scale of temperature because in this we get the concept of absolute zero. Absolute zero means even if we have a 0 degree Celsius temperature, it means we have Kelvin at 273 degrees, 273 Kelvin. But suppose if the value of Kelvin is 0, if the value of Kelvin is 0, so the temperature in Celsius scale is minus 273, and we cannot get a temperature which is less than minus 273 degrees Celsius or 0 Kelvin. We cannot have a temperature less than 0 Kelvin, right? Physically. So Kelvin is known as the absolute scale of temperature. So let us change the Charles law from degree Celsius to temperature in Kelvin. So we can write Vt is equal to V0 273 plus T divided by 273. So we can write Vt is equal to V0 into T, capital T, divided by 273, right? Similarly, if we have another temperature, right? If we have, see, this temperature Vt is at suppose T, so we again have another Vt dash. If we have a temperature Vt dash, that will be equal to V0 into T dash divided by 273, right? We will have this temperature because instead of 273 plus T, instead of 273 plus T, we will have V0 273 plus T dash, and that is written as V capital T dash. So from here, what we can write is, we can write V0 VT by VT dash is equal to capital T by capital T dash. So from here, we can easily write V1 by V2 is equal to capital T1 by capital T2, where T1 and T2 are the absolute scale of temperatures, where T1 and T2 are the absolute scale of temperature. So Charles' law can be modified, right? Charles' law, the statement of Charles' law can be modified as the pressure remaining constant, the volume of a given mass of any gas, right? The pressure remaining constant, the volume of a given mass of any gas is directly proportional to its absolute temperature, is directly proportional to its absolute temperature. So let me write it. The pressure remaining constant, the pressure remaining constant, the volume of a given mass of remaining constant, the volume of a given mass of any gas is directly proportional to its absolute temperature, is directly proportional to its absolute temperature. Absolute temperature. Pressure remaining constant. Volume of given gas is directly proportional to its absolute temperature. V1 by V2 is equal to T1 by T2, or V proportional V proportional T. So this is Charles'